Welcome to Math with Professor V. Here is your latest integral of the day. We have an indefinite integral of y to the fourth plus y squared minus 1 over y cubed plus y dy. And just as a hint and warning as you begin, make sure you long divide first before you try to do any other integration technique, okay? All right, so anytime you have a rational function as your integrand, and the denominator is not of a higher degree than the numerator, you need to long divide. My pre-calculus teacher in high school said you needed a J-Lo fraction, higher degree in the bottom heavy. Oh, poor J-Lo, she's really been through it. Anyways, so to start off, I'm going to take y cubed plus y and long divide it into the numerator. Everyone learns long division differently. I was taught to put placeholders, so that's what I'm going to do. So there's no y squared term. I'm adding that in to the divisor, and then I'm going to divide that into y to the fourth. Let me put 0y cubed. I need a placeholder there, plus 1y squared plus no y's minus 1. And then just pay attention to the leading term. So what do I multiply y cubed by to make it y to the fourth? Just y to the first, and I distribute that to the divisor, write it underneath. So this is y to the fourth plus 0y cubed plus y squared. And then now I subtract this from the row up above, and then look, everybody cancels. Boom, boom, boom. 0y is nothing, and I'm going to bring down the next term, which is a -1. And actually, this long division has come to an end. That's my remainder. How do I know this is my remainder? Well, it's of a lower degree than the divisor, so I can't divide y cubed into -1. If this was y or y squared even, it would still be my remainder. Only if it was y cubed or higher could I keep going. So we're done. So if that's my remainder, then that means my quotient is y, and then my remainder I would write as -1 over the divisor, which was y cubed plus y. So that's how we're going to rewrite the integrand now. So we've got integral of y minus 1 over y cubed plus y dy, like that. Okay, good. So hopefully looking at this now, you're like, why? I can integrate that, no problem, even on a bad day. 1 over y cubed plus y, let's go ahead and do partial fractions, find the decomposition, and then hopefully we can integrate with some ease. I'm going to ignore the minus sign, but just don't let me forget it after, guys, okay? Thank you. So we have 1 over, let's factor that denominator. I can take a y out, and then you have y squared plus 1 left, right? Then my decomposition will have the form a over y, just a constant, plus, and then notice y squared plus 1, that's an irreducible quadratic. It can't be factored any further. So the numerator will have the form by plus c. And then next step, I multiply everything by the LCD, which is y times y squared plus 1. And then now we have 1 equals a times y squared plus 1 plus by plus c times y. Now my job here is to solve for a, b, and c. So let's go ahead and distribute everything out. This is 1 equals ay squared plus a plus by squared plus cy. And I'm going to set the coefficients of like terms equal to each other. So this is what I mean. Starting with the highest power term, y squared. There's no y squareds on the left. So 0 must equal a plus b. Okay, great. Y to the first. Do you see any y firsts on the left? I don't. Do you see any y firsts on the right? Yeah, c y to the first. So 0 must equal c. Do you see any constant terms or y to the 0 on the left? I see a 1. So that means 1 must equal the only constant that's on the right, which is a. Perfect. Because if 0 equals a plus b and a is 1, then I know b is -1. Beautiful. So now we can go back, rewrite our integral. So we have, and remember there was that negative, thank you guys for reminding me, minus, which I'll have to distribute. Okay, so we've got integral y minus a over y minus, I put minus because b was -1. Am I freaking you out? I feel like I did. I should put plus -1 plus 0. Let me do that so nobody has a panic attack. Plus -1 times y plus 0 over y squared plus 1. Okay? Don't want anyone traumatized. Okay, so here we have integral y minus 1 over y, and then this is now, plus y over y squared plus 1 dy. Good, good, good. We should be able to just go term by term. Depending where you are in your calculus career, you might need to do this one off to the side and do a little u-sub, but once you get a lot of practice, you'll do it in your head. So here we go. Antiderivative of y is just 1/2 y squared. Next term's minus natural log absolute value of y. And then lastly, I have plus 1/2 natural log y squared plus 1. I don't need absolute value because that's always positive, plus c. If that was a little too quick and you're like, where'd that last term come from? Then just take the time right now off to the side to just do the integral y over y squared plus 1 dy. You would let u be y squared plus 1, right? And then du is 2y dy. See how all that happens is I pick up a 1/2 and the whole numerator gets absorbed? Yeah, so 1/2 du over u. Exactly, so then you have 1/2 ln absolute value of u. I'm going to say plus d because I already used up c. So it's 1/2 ln and then y squared plus 1. Now, how did I do that in my head? I've done so many, you guys. And once you've done, a few hundred, you'll be there too. I've done thousands. This is u. In my head, I go du would be 2y. I literally just imagine this first line and I go, oh, there's going to be a 1/2. And then you're going to have just u in the denominator. So it's ln of the denominator. Okay. But if that felt like too much to skip it, then take the time to write it off to the side. Don't force yourself to take shortcuts. I think skipping steps is great when you feel comfortable. Don't push yourself to get there. And if you're not there, then that means you just need more practice. That's all it is. Okay. But as a professor, as an instructor, I never discourage my students from doing things like this because a lot of it will help you, especially when you're in Calc 3 and you have such complicated integrals that are time consuming. These can be really helpful. Okay, enough of that. I hope you like this integral. Hopefully it helped you review a lot of important techniques like long division, partial fraction decomposition, and all that good stuff. So don't forget to give it a thumbs up, subscribe if you haven't already. Follow me on Instagram and TikTok, Math with Professor V. You can see all my shenanigans there as well. And I will be back with more calculus uploads in the coming days. Thank you guys. Bye.